This video series is educational in nature rather than advisory. It is always important to consult with your financial advisor before investing. Position Sizing Technologies. Position sizing is a trademark of Position Sizing Technologies. Dr. Van Tharp's Secrets to Profits, the Position Sizing Workshop. This workshop is about position sizing, and it covers strategies that control how much you should invest in any investment or trade throughout its duration. It's the key to meeting your objectives in the market.
Hello, I'm Dr. Van Tharp. I've been working with traders and investors since 1982, and I teach you how to improve your profits with less stress just by changing your thinking. This series, which we call Van Tharp's Secrets to Profits, the Position Sizing Workshop, continues in that vein. When you apply this material, you'll increase your profits and also improve your chances of survivability in today's volatile markets. So watch this series and you'll learn a step-by-step procedure for increasing your profits and surviving in today's volatile markets. Let's get started.
Before we talk about specific strategies, there are certain key topics you need to understand. These include R multiples, expectancy, and how to simulate your system. First, let's talk about R multiples. Dr. Tharp is now going to explain the concept of R.
The first concept is what I call R. And basically, this is your risk when you first get into a trade. In other words, when you first enter into a trade, you have to have some point at which you say, I'm going to get out if it goes this against me by this amount. That's R. Now, R could be a formula. It could be 3 times the average true range. It could be a money management stop. It could be anything, but R is your initial, at least by expectation, your worst case risk when you get into a trade. Theoretically, it's your worst case risk, but psychologically, you might let it go away and you could have a risk that's much bigger than R. The market could gap against you. So it's you want most of your risk to be 1R, but it's conceivable to have losses that are as big as 5R, and maybe for the average person 20R, because they don't use stops. Now, I think some people have a problem with R because it'll vary all over the place. In one trade, it might be one thing, in another trade, it might be something else. So it's hard to conceive of what exactly it means. But what's really important in simulations and what's really important in money management is a way to go across every possible product you can have, whether it's different stocks with different costs, whether it's different commodities with different costs, or whether it's options. You can actually put all of those in the same basket if you think about R. And what happens is, what you have now suddenly is a common language. You can say, if let's say R is $3. This is an example, it's $3. Now, if the market moves up by $30, you suddenly have a 10R gain. If it goes against you, gaps against you, and you have a $9 loss, you have a 3R loss. But that R value is common across, you can do several systems at the same time with R. You can do all kinds of, you can mix and match, and the concept of R stays constant. In addition, if you use like a percent risk, where 1% of your equity is tied up in R, then 1R becomes very constant throughout. It basically implies 1%.
To recap the example, if R equals $3 and the market moves up by 30, you have a 10R gain. If the market gaps against you and you lose $9, that equates to a 3R loss.
When you're doing R, you have to take out the effect of position sizing. But R is also, if you take your total risk at the beginning, so let's say you have a $2,000 risk at the beginning. Maybe it's a $20 stock and you have 100 shares of it. But you have a $2,000 risk at the beginning. Your profit ends up being $40,000. With this alone, you can switch this to an R multiple. Basically, you have a 20 R gain.
If you divide your total profit or loss on a trade by your initial risk, or R, then you've just expressed that gain or loss as an R multiple.
You have to know the distribution of R and your R multiples in order to simulate a system. That's one of the real keys. You really have to know the distribution of R and their R multiples in order to simulate a system. Knowing the total profit of a system doesn't mean anything, but being able to know that distribution is everything in terms of simulation.
Our second key topic is expectancy, where expectancy tells you how good your system is in terms of R.
Secondly, if you know your R, then you can very easily figure out what expectancy is, where expectancy is something that will tell you how good a particular system is. And in this case, I'll give you a couple of formulas that make it easy. I've given lots of formulas, but I'm going to try and get this down as simple as possible. So the simplest formula the sum of the R multiples, all of the R multiples divided by the number of trades. It's a very simple operation for a computer to do. It just has to add these up. So, if you have two 20Rs, it'll add those up, and 3 minus 5Rs, it'll add those up, and then divided by the number of trades, you'll basically have your expectancy in the system.
For example, a system with an expectancy of 0.5 means that you make, on the average over many trades, 0.5 R per trade. A system with an expectancy of 2.0 means that you'll make an average of 2 R per trade over many trades. Thus, the expectancy of the second system is 4 times as good as the first system over the same number of trades. We're going to play a trading simulation game in which the R multiple distribution will be represented by marbles in a bag. The game, in other words, is a simulation of a trading system. When you start playing, you will begin with $10,000. Your objective is to make as much money as you can. For example, if you make over $50,000, you'll beat everyone in the audience. See if you can do that. Now here's Dr. Tharp to tell you about the marbles.
There's 10 blue marbles that win 1-to-1. There's 6 white marbles that win 2-to-1. In other words, it's a 2R multiple. There's 2 red marbles that win 5-to-1, and 1 pearl marble that wins 10-to-1. So there's 19 winning marbles. There are 20 black marbles that lose 1-1, 5 red-yellow center marbles that lose 2-1, and 1 white center marble that loses 5-1. So there's 26 losing marbles. That's basically the distribution in that bag.
Before each marble is drawn, decide how much of your capital you will risk. When a marble is drawn, we'll tell you what the R multiple is. Multiply the R multiple by the amount you risked to determine what you've won or lost. For example, if you risk $100 and a 10R winner is drawn, then you will have made $1,000. On the other hand, if you risk $100 and a 2R loser is drawn, then a $100 risk would result in a $200 loss. Once you determine what your profit or loss is, add that profit or subtract that loss from your last equity to determine your new equity. Once you've done that, your job is simply to determine how much you'll risk on the next trade or marble draw. Notice that all you are doing is determining how much, which is what position sizing is all about. The expectancy of the marble bag is equal to the sum of the R values of each marble divided by the total number of marbles. Thus, the expectancy of the marble bag is 0.16 R. In other words, you can expect to make 0.16 times your risk for each marble draw on the average.
Okay, this part of the room, I want everybody in this half of the room to go for the moon. We're going to play 25 trials, and there's no prizes or anything involved in this. It's just an illustration. I want you to go for the moon. I want you to make as much money as you possibly can. That's your only objective. Just these sets of tables, this set of tables here. This whole group, 4 tables. This group in the center, I want you to make as much money as you can, but at no cost. I want you to avoid, like the plague, any kind of loss or drawdown greater than 50%. That's your objective. 50%. So I mean, if you risked it all, you're really risking going for the. That's not fitting within your objectives. Those guys can risk it all. You guys, I want you to play this game. I want you to make as much money as you can, but your overall goal is no more than a 10% loss, or no more than a 10% drawdown. Okay? So what we're going to do is we're going to look at the distribution. Everybody's going to get the same trades, the same R multiples, and what we're going to do is look at the distribution of them, of the results at the end. 10,000 is your starting equity.
Here's an example. Suppose you risk $100 on the first marble pull.
2R winner.
In this example, a 2R winner was pulled. You've won twice the amount you risked, or $200. Thus, your new equity would be $10,200. However, that one didn't count. It was just to show you what to do. So determine how much you want to risk before the first marble is pulled. Write down that amount. Are you ready? If you need more time to play the game, please be sure to pause the tape.
You got 10,000 in starting equity. Put your initial bet down. Everybody got your initial risk down? Well, we start out with a 5-1 loser. Okay. No, you're bankrupt now. Now we have a 1-1 loser. We have a 2-1 winner. We have a 1-1 winner. We have a 10-1 winner. We have a 2-1 loser. We have a 2-to-1 winner. A 2-to-1 loser. A 1R winner. A 1R loser. Just out of curiosity, how many are bankrupt? My whole family is bankrupt. They're on the go for it side, so that's not too bad. We have a 1R winner. One R loser. Five R winner. One R winner. Two R loser. One R loser. One R loser. This is the 18th pull. One R loser. One R winner. That is a 2R winner. One R loser. One R winner. One R winner. One R loser. One R loser.
Here is the R multiple distribution of the sample of trades you just got. You can determine the expectancy of the trades by summing the R multiples and then dividing by the number of trades. In our sample, our R multiple total was plus 10R. When you divided 10R by 25 trades, you get an expectancy of 0.40. That means your average gain per trade was 0.4R. See how it works, and you can do that with your own trading. Also notice how the one 10R marble amounted to the whole expectancy of the game. This is also similar to what happens in the markets. One trade or one investment makes up your entire gain. Notice that the sample expectancy of 0.4 is better than the expectancy of the marble bag, which is 0.16. This will happen about half the time. Dr. Tharp has just sampled the final equity for every individual in each group. Notice almost everyone will have a different equity. In addition, those equities are influenced by the group objectives.
We only had one duplicate except for the zeros. You know, almost 30 people in this room playing the game. And look at the distribution. Highest number is on the ones who got to go for it. But we also had 1, 2, 3, 4 bankruptcies on that side and 5 losers. Half of them, almost half lost money. On this side, we only have 2 losers, but we're getting up to half as much as this. And on this side, we don't even go as high. Our high is 12,000, but we only have 1 loser. Again, it shows something about, and everybody got a different amount of money, or you all got the same trades, but the dispersion varies all over the place, and it varies very much according to your objectives. So the key point of this is how important bet sizing is and how important objectives are to bet sizing. Now, with that in mind, let's take a break for just a minute. We're going to set up the next section.
Notice that with a few exceptions, everyone ended up with a different ending equity, yet everyone got the same trades. Only position sizing was involved. Notice that each group had a different equity distribution at the end. This shows that objectives determine position sizing strategies and are also critical. Hopefully, you are beginning to understand just how important your position sizing strategy is to the final results. You can make a lot of money or go bankrupt. It all depends upon your position sizing strategy.
When you look at there's really two different strategies for bet sizing according to the gamblers. There's the anti-martingale and the martingale strategy. Martingale strategy is where you increase your bet size when you lose. And the typical one that we mostly hear of is where you double up when you lose. For example, you might go into a casino and say, okay, I'm going to bet on black on roulette. And every time I lose, I'll double my bet size. Which means when you eventually win, you win $1 out of a streak. And you win $1 out of every streak, assuming you start with $1. There's a little problem with that because you have just under a 50% chance of winning. With 50%, you can have as many as, well, in 1,000 rolls, you'd probably have a streak of 10, 12 in a row. And if you happen to get one of those particular streaks, maybe you'd be lucky and you wouldn't get one. But if you happen to get one of those streaks, after the 10th bet, you'd be risking $4,096 to get back to even and win $1. In other words, your risk to make $1 would be over $8,000. The casinos, of course, have betting limits. And if you had a table that allowed you to risk $1, it would never allow you to have a maximum bet that large. So it's doomed to failure. If they didn't have maximum bets and you had an unlimited bankroll, you'd have a potential of winning there. You could win doing that. Same goes, but generally these kinds of strategies don't work. The gamblers find they don't work, and they don't tend to work in the markets.
Martingale strategies, where size goes up as you lose, do not work.
What works are strategies where you increase your bet size as you win. And anything that's based on equity, where you're allocating a percentage of equity according to some formula, is what we would call an anti-martingale strategy. And in other words, if you have 1% of equity, a 1% risk would be an anti-martingale strategy. On $1,000, you'd be risking $10. On $1,200, you'd now be risking $12. So obviously, as your equity goes up, the amount you put at risk goes up. So these are the kind of strategies that work.
Notice that when you risk a percentage of your equity, you are using an anti-martingale strategy, and this sort of strategy is excellent unless you risk too high a percentage.
The one exception possibly, Jack Schwager mentioned in his book, if you have money with different money managers, what tends to work is if you quarterly, say you had money with 5 different money managers, and they're fairly non-correlated, if every quarter you divided your money or you took evenly between the money managers, you're taking away from the winner and you're giving to the loser, you tend to do better that way. Overall, you certainly tend to have a smoother equity curve. And you could probably do that with systems too. If you have 4 or 5 systems going that are non-correlated, every quarter you divide your money equally among the systems. You'll probably do better and have a smoother equity curve than if you just let the hot system go off and accumulate all the money. There are 3 kinds of equity models. How do you determine what your equity is? There are 3 kinds of equity models. The first one is total equity. This means if you have, say, $100,000, you open up one position, say you're risking 1% or $1,000. So 1% equals $1,000. Now the next day or the same day you open up another position at 1%, that's another $1,000. And another position at 1%, that's another $1,000. Basically, when you're using a total equity model, what's going on here doesn't, taking money into these positions doesn't affect the total equity, or is taken into consideration. Now, this is the most aggressive approach. Second approach is what we call, the most conservative approach is what I call core equity. What happens with this, we have our same $100,000. So you take a 1% position, which is $1,000, you now subtract that, and you have $99,000. And the nice thing about this is you consider this particular allocation gone until it's closed out, which for a lot of you, it might be gone anyway. If you have a good system that has high R multiples but is wrong 60-65% of the time, it's probably gone. So you just assume it's gone. The next position now is 1% of the core equity, or 990.
As Dr. Tharp has clearly illustrated, core equity is based upon your cash and has nothing to do with open positions.
So you keep subtracting from the core equity until these positions are closed out, and then they can be added back in. This has some psychological advantages because you basically just assume that that position is gone until it's back in there again. And you know what the allocation is. If it's just 1%, no big deal. Now, third model is what I call
Reduced total equity. Position sizing is only based upon your cash equity plus the money you lock in when you move your stops.
reduced total equity. It's a little bit like the total equity, but it's slightly reduced. What happens is, here's your 100,000. We'll still use the risk parameters. First position is $1,000, 1%. Now it's considered gone until you raise your stops. When you change your stops, you change what happens to this position. You can add back in what you've done. So for example, let's say to start out with, your reduced total equity is the same as core equity, it's 99,000. But now this one happens to have your stop goes down to $500. You only have $500 at risk. Now you have $99,500. Now what might happen now is at some point in time, so with this amount you have 99,000. When you suddenly raise your stop so that the risk is only $500, you now have 99,500. If you now start to get a profit, let's say it goes to, make these minuses, now it goes to plus 500. Now you have $100,500. And that would be the same as, in one sense, this model here. If this part went up, if this position here went up to where it was adding $1,000 into the equity, it would be added in. So if this position is now worth $1,500, let's say this position goes up and it's now worth $2,000. This position now goes up and it's now worth $10,000. And this position goes up where it's now worth $3,000. You have $12,000 new equity. This $1,000 has to be subtracted, so now your total equity would be $112,000. So this is the value of cash plus the value of all your open positions. Robert? Yes, but the initial 1,000 was included in that. So the question was, where do I get the 12,000 instead of 15? Well, you had 1,000 included in the initial allocation. Now in this particular one, you're not adding that 1,000 back in. So this position is really, you just have a $500 profit here. You still might have this position might be up $1,500, but you only have a $500 profit that's protected by the stop, so that's all you'll add back in. So you only add it back in whatever is protected by your stop. And that's the difference in these two.
Here are the key points you need to remember. R represents your initial risk when you enter into a position, and it is determined by the difference between your entry price and your stop or bailout point. Your goal in trading is to have losses that are 1R or less and profits that are large R multiples. Expectancy is a measure of how good your system is in terms of R. In our trading game, we made an average of 0.4R per trade. Expectancy can be calculated by summing your R multiples and dividing that sum by the number of trades. If you have an R multiple distribution from a sample of trades, you can simulate that system as we did in the marble game. Through these simulations, you can practice various position sizing strategies to see how they will perform. Except for those who went bankrupt, most people had different results in the game. Thus, position sizing is very important in influencing your final equity. Objectives influence position sizing and thus the nature of the results. In addition, position sizing is the key to meeting your objectives. The only position strategies that work are anti-martingale, where position sizing increases as your equity increases. There are three possible ways to determine your equity: total equity, core equity, and reduced total equity. You should review this tape until you understand these key points. They are critical to comprehending the material that follows. This concludes Tape 1. Dr. Tharp's Secrets to Profits, the Position Sizing Workshop continues on Tape 2.